Okay, AP Chemers, here we go. Broadcasting from the hospital. Yeah, so things are happening. We'll get through the lesson, 15 or 20 minutes. You guys will have the rest of the period to work on your online homework stuff. And test coming Monday, Quizorama Friday, got your quiz tomorrow and stuff like that. So, yeah, so we'll do the best we can with all that sort of stuff. And we'll just kind of forge ahead. Okay, so here we go. So we're going to do delta G a little bit more today. And we're going to be looking at when the equilibrium is not at standard conditions to determine which way the reaction is going to get to go to equilibrium. So we're basically, when we're talking equilibrium, we're talking about K, and we're probably going to do a little Q today as well. So here we go. So in terms of the bell work, the sign that indicates that for delta H indicate exothermic reaction. Hopefully we got that as negative. The sign that on delta S indicates that this order of the reaction is increasing is going to be positive. Okay, and then sign on delta G, we got a spontaneous reaction is negative as well. Okay, so a couple things in terms of thermo and equilibrium. You got a system at constant temperature and pressure is going to proceed spontaneously in the direction that lowers its free energy. So you can kind of think about that in terms of a well. Like you've got your reactants over there, you got your products on the other side, and that in terms of equilibrium, right? It's the amount of products to reactants. It's kind of like a well, and it doesn't necessarily have to be in the middle. That's going to favor, but it's kind of the bottom of the well energetically there, where it's the lowest amount of free energy. So that's where you're going to reach equilibrium, where the energy is the lowest between the two there, to some extent. So in terms of our equilibrium, there's a few equations here that we want to be made aware of, okay, and a couple of them that are most important for us, which are these two right here that I'm starring, okay. The one on the left is going to be very useful to us in terms of solving for Q, and when it comes to the delta G standard, right, remember that we can also solve for delta G standard in terms of the sum of the products minus the sum of the reactants, okay. One thing that we want to be aware of with R, the R value you want to use, right? If you look at that, that's in joules. We want kilojoules, right? So we always want to be operating there. So we're going to use 0.008314 kilojoules per mole per K, all right, for Kelvins, and that sort of stuff. So, and just as a reminder, equilibrium constant, a lot of times when we're going to be looking at these ones, we're looking at, they tend to be in atmospheres and things like that, so it's going to be, it's pressure of the products over pressure of the reactants. Okay, so we'll do a little bit of that today. So in terms of what does the value for delta G mean, okay, notice you're not necessarily at standard condition because there's not that little degree sign above the G, so we'll talk about these in a little bit here as well. So let's just start working problems. Okay, so first question here, delta G, 25 degrees C. So ultimately that's 298 K. For the reaction carbon monoxide, you got 5 atmospheres and 3 atmospheres are converted to liquid methanol. So you've got carbon monoxide and hydrogen gas. Here's our balanced equation. We got to have that guy written out. Oh, okay, so our K dq here is going to be, because this is liquid, right? Both of these are gases. So when we write out our equilibrium constant, this guy's going to be the pressure of carbon monoxide times the pressure of hydrogen gas squared. Okay, so that will come in handy for us in a little bit, because ultimately we want to find delta G, not at standard condition here, but we're going to use the equation delta G standard plus RT and L of Q. So I call that delta G Q plus Ratlink, okay? So RT, L, and Q. So we got to find delta G standard. So remember, delta G standard is equal to the sum of the products minus the sum of the reactants, okay? So our products here are going to be just our methanol there. So that's negative 166 minus some of our reactants. So we've got hydrogen is 0, and then carbon monoxide, so a negative 137. So that ultimately gives us a total of negative 29 kilojoules. I've already got these kind of worked out and stuff, so if you need to pause the video, make sure you just pause the video if I'm going a little too fast or whatever, okay? So what we're going to do then, since we have delta G of naught or standard, we're going to plug that into our equation and everything else as well. So we've got delta G is equal to negative 29 plus R, which is 0.008314 times 298, okay, times the natural log of Q, right? Because Q is the same expression as K. It's just going to be 1 over 5 times, and the pressure of hydrogen was 3 squared, okay? So ultimately, delta G, do some math here. Negative 29 plus, what's that, 0.008314 times 298 times the natural log of 1 over 45. Okay, so if we work out the math for that, the delta G is equal to negative 29 plus a negative 9.43. We get a total of a negative 38.4 kilojoules. So if that's the case, that means that the reaction will move towards, towards the products to reach equilibrium. Okay, because we end up with a negative 38 there. Is that right? Yeah, okay. So that's good. Okay, so with when you end up with that. So remember on the front side, this is what we're talking about on that first page when we're talking when you find that delta G. That's going to help you decide which way the reaction is going to move to get the equilibrium, because ultimately we're comparing K and Q. Okay? All right, so if we move to our next exercise here, number 2. So there's our balanced equation. I'm just going to write the K expression over here just so I have it for later. So the pressure of ammonia squared over pressure of nitrogen gas times the pressure of hydrogen gas cubed. All right, so they give us a couple different scenarios. They give us the delta G, so that worked out nice. And it's T is at 298 for each of them. And they want us to predict which way the direction is going to go. So the nice part is we can just kind of plug these in. So for part A, we got delta G is equal to negative 33.3 plus, we're doing RT ln of K again. Well, ln of Q, so we don't know whether or not we're at equilibrium or not. So negative 33.3 plus 0.008314 times 298 times the natural log for that first one is going to be 1 over 1.47 times 1 times 10 to the minus 2 cubed. So ultimately, we work that out a little bit here, and we'll notice that it turns out to be 0. Delta G equals 0. So what's the deal with that? Well, that just means we're at equilibrium. All right, for that first one, when delta G equals 0. So I'll put those up over here off to the side. When delta G equals 0, we're at equilibrium. When delta G is less than 0, the reaction will shift right. When delta G is greater than 0, the reaction will shift to the left to get to equilibrium. Okay, so then for part B, we just kind of plug and chug these in. Remember, if I'm going too fast, pause the video, because I'm kind of flying right now. So 0.008314 times 298, and then we sub those in. So we got the natural log of, oh, look at that, everything is 1. So yeah, so if everything is 1, I don't know if you guys remember what the natural log of 1 is, but ultimately that goes to 0. So 0 times all that sort of stuff, so delta G is equal to negative 33.3 kilojoules. All right, so it's negative, so that means the reaction will shift to the right. to reach equilibrium. All right, so there's the next sample problem there. All right, final problem. We got one more to work here. Okay, and they give us the overall reaction. Hey, rust. We all know this reaction is spontaneous, right? So let's try and calculate delta G standard for this guy. That's ultimately what they want us to do here. So remember, but we want to find the equilibrium constant for this guy. And we're going to use, so we need to use our formula of delta G is equal to negative RT ln of K. But in order to get there, right, we need to know what delta G naught is here, right, to find the natural log of K. So in order to solve for delta G standard, remember that guy is equal to enthalpy minus T times delta S, right? They give us our two delta H, delta S quantities here. So let's solve for delta H. Oops, move this right over here to get me a little centered here. So delta H, remember it's just products minus reactants. So sum of the products minus sum of the reactants. So it's equal to, nice part is here we only have products, so it's negative 826 times 2, right? So that's going to be our delta H for this guy, 826, 1652, negative 1652. And our delta S is also products minus reactants, so we're going to have 2 times 90 minus 4 times 27 plus, what's that, 3 times 205. So ultimately we end up with here a negative 543, that's joules per mole K, which is ultimately equal to, remember, negative 0.543 kilojoules, right? Because we want everything in kilojoules, and we're all set. So we got delta S, we got delta H, we plug those guys in to find delta G. So delta G that is equal to negative 1652 minus 298 times a negative 0.543. So ultimately our delta G naught is equal to negative 1490 kilojoules. And now we're ready to plug that into our equilibrium expression formula over here. So we can find our K value. So negative 0.008314 times 298 times the natural log of K. So let's solve for K. So negative 1490 is equal to okay, so we've got, that ultimately turns out to be negative 2.478 times the natural log of K. So the natural log of K is going to be equal to 601. So if we do e to the 601 equal to K, ultimately you're going to get like an error on your calculator because it's so huge. Okay, that means, yeah, products are slightly favored. Are favored. Okay, that's why if you put iron out in sooner or later, it's going to rust. There is nothing you can do about it. It will rust. All right, so yes. All right, that's it for today. Get going on your online homework. I know we whipped through this pretty quickly, but yeah, check it out again if you need to. And that's all there is to it for today. Quiz tomorrow. Quiz-a-rama Friday. Test. Make sure you get the review guides and all that sort of stuff today. That would be a good idea to get those reviews for the multiple choice and the free response for the test coming up. Okay? All right. Over and out. We'll see you when I see you.